When we're talking about memory, we are referring to a form of data storage. Whereas disk storage is considered longer term, random access memory, or RAM for short, often just called memory, is short-term storage. As illustrated earlier, RAM is used to store data and instructions for the CPU. If you're running a program, that's in RAM. If you're browsing a web page, that's in RAM. Anything that's currently happening on your computer is currently stored in RAM. RAM is significantly faster than disk storage, but it still lags far behind the performance improvements of CPUs. Remember again my discussion on the memory wall versus Moore's law in the introduction chapter. RAM has much more capacity than a CPU's cache, but it is significantly slower than a CPU cache. So there's always this trade-off between more capacity and more speed. A small CPU cache, while it's fast, has the risk of a cache miss, which means that the necessary data is not in the faster but smaller CPU cache. This will force the CPU to cascade up the levels of the cache to eventually fetch data from memory, which is larger but significantly slower. CPU cache will usually be measured in megabytes, while RAM is measured in gigabytes. RAM is also volatile, meaning that when power is interrupted, the data that is stored in memory is lost. RAM is considered a form of primary memory on a computer because it is the main memory space for the CPU to access the data that it needs. Disks are considered secondary memory. This table summarizes some of the differences between primary memory and secondary memory, but we're not going to focus on this information. It's here if you want to pause and take a look at it later. The term random access memory simply means we can access any address in memory without first needing to go through all the memory locations. This is juxtaposed against a sequential access medium such as a tape storage. With such random access memory, we can arbitrarily access any part of memory. There are two types of RAM. There's DRAM, which is dynamic RAM, and SRAM, which is static RAM. Static RAM retains its data while power is supplied to it, while dynamic RAM loses its data even while power is supplied to it, which means we have to read out the memory data and then write it back into memory repeatedly. Static RAM is significantly faster than DRAM. So on the surface, SRAM looks like a lot better option to DRAM, but SRAM requires several transistors per bit, whereas DRAM uses one transistor per bit. So we can get a lot more DRAM per unit area than we could ever do with SRAM. So on that side of it, DRAM is the popular and cheaper alternative. The cost of refreshing RAM is relatively negligible and is considered a worthwhile price to pay for the higher capacity and cheaper RAM. Again, it's that principle of pain versus gain. The pain of refreshing RAM is outweighed by the gain of having much more and much cheaper RAM available to us. The most common type of memory that you will encounter is dual inline memory modules with the acronym DIMM, D-I-M-M. Like most other components, DIMMs come in many shapes and many sizes, so you need to be sure that the DIMM you select for your system is compatible with the motherboard and, to an extent, the CPU as well. DIMMs are also measured in different speeds and they will offer different performance. There's a lot more thought process and planning that can go into implementing RAM at optimal speeds, but because this is an introductory chapter, it's sufficient to know that there are different types of RAM for different speeds for different motherboards, and you should be careful about your selections when making your configuration.